Hey, in this video, I'm going to walk through how to do all the things for standard form. First, how do I know this is standard form? There's no parentheses, and the other giveaway is that there are two x's in my equation. Now, if this was a test, the top of the page where there's going to be formulas will be the formulas for standard form. So that's the other giveaway there. Okay, now, just to run through everything, standard form follows the pattern of ax squared plus bx plus c. We were doing a lot of this with factoring. It's all the same thing. So as I start going through some of these answers, this is going to be where I pull numbers. For example, a is -1/4, b is -2, and c is 3. So my y-intercept, the definition of it, is what is y when x is 0. I could plug in 0 for x, however, it will always be my c value. And it's 0, 3 because it's on the y-axis, that's when x is 0. Okay, next, the axis of symmetry. The equation for this is the opposite of b divided by 2a. So what this is going to look like, it is the opposite of b. My b is -2. The opposite of -2 is 2 divided by 2 times -1/4. Okay, then on a calculator, I would start typing stuff in. I do the denominator first. 2 times -1/4 is -1/2. Then I would take 2 divided by -1/2, and I get -4. Now I'm going to erase, some of this. So again, it's the opposite of b divided by 2 times a. So I took 2 divided by 2 times -1/4. I also need to point out this 2 right here will always be there. Okay, next I'm going to plug in or find my vertex. So just like with standard form, when I plug numbers into the equation, I'm going to do the same thing here. I'm going to plug in -4 every single time I see an x. So I have -1/4 times -4 squared minus 2 times -4 plus 3. Okay, so when I type that into my calculator, -1/4 times -4 squared minus 2 times -4 plus 3 gives me 7. So my axis or my vertex happens at -4, 7. I'm going to put a dot right there. Now, opens, min, max, if it's going to be wide or narrow, all of that could be found by just the a value. So like I could look at a and go, oh, hey, that's negative. It's going to open down. I'm going to have a max. Or you could graph it. And when I go to graph it, it's going to be the same thing as when we did our graphing in vertex form. So I need 5 points. Here's 1, 2, 3, 4, 5. I'm going to try to make sure I have enough room here. Okay, and my vertex happens 1, 2, 3, at -4, 7. And I'm going to count down to -5 and -6, and I'm going to count up to -3 and -2. I also know that my y-intercept is going to happen way over here. And this is 1, 2, 3, 4. So 1, 2, 3, 4. Now what I'm doing is I said, hey, I knew my y-intercept happened over here. How did I get here? I went to the right 4, and I went down 4. What that means on the other side of my equation, because again, we have this axis of symmetry, instead of going to the right, I can go left 4 and down 4, and I also have a point. This is going to help me because of the fraction. When I start plugging these numbers in, I'm probably going to get a couple of decimals. So this will help me kind of keep everything ideally on a line. Now, just like before, what I'm going to do is I'm going to take these numbers and I'm going to plug them into my equation. So I have -1/4 times -5 squared minus 2 times -5 plus 3. Again, I'm using this equation up here. Now, I apologize in the background, the light in my room just went off, so I couldn't see my calculator. So I would type -1/4 parenthesis -5 squared minus 2 times -5 plus 3, and I get 6.75. Okay, and I would repeat this with -6. -1/4 times -6 squared minus 2 times -6 plus 3. Okay, and that gives me 6. Now, I can, here's -5, I can try to estimate, right? I can say, hey, at -5, I'm at -6.75, and that's almost 7, right? I am putting an orange dot there for an estimate. -6 gives me 6. And you can start seeing how these points all line up, right? The orange, the pink, the blue. Even though when I drew my orange dot, it was more in the middle than like 3/4 of the way there, to make the dot big enough so that you can see it, notice how it takes up most of the space and it's not touching the lines 6 or 7. That is an unfortunate placement of the dot. But when I go to graph this line, we can see how it already all forms perfectly. Now, when I go and I type in -3, -2, I should be getting the same things, right? This is a good way for how we can check our work. If I plug in -3, I better get 6.75. Neat, I do. If I plug in -2, I better be getting 6. Neat, I do. So I'm going to use -2, 6. I'll call that my 5th point. And then my graph goes like this. And again, make sure to draw the arrows so you show the graph goes on forever. As you are watching this, I need you to notice the graphing between vertex and standard form is the same. It is the same because the really great way to graph standard form is using x-intercepts. However, to get those, we need to solve, and we haven't done the solving unit yet. Otherwise, this is how I do all the things for standard form. Let me know if you have questions, but otherwise, that's it.